Alright guys and gals, this is take 2 for balancing practice number 1. I think I've got everything figured out, so let's give this a shot. Now, if you guys will notice, up here at the top, right up here, you'll find a copy of this handout. If you'd like to print it out and work it along with us, that would probably be pretty smart. Now, if you have this thing right here, down here in the corner right here, you should find a button that should make this video larger. And at any time, if you'd like, hit the space bar, and that'll pause this video. I recommend that after working a few problems with me, hit the space bar, pause it, work the problem yourself, and come back and see if you got it right. Anyway, let's go ahead and work through this first problem. Now, just like we've done in the previous ones, draw a line down. We want to separate the reactants, which is everything over here on the left, from the products, which is everything over here on the right. Okay, a quick reminder, we try to balance in this order. Usually you want to start with metals, do all others, except for H, and then O. You kind of want to do it in this order, guys. Metals, especially transition metals if you have them, get everybody else, do the H's and do the O's, in that order. Now over here, let's break this thing down. You've got Fe, you've got O, and you have H. Hey, look, some more O's. So, Fe, H, and O is what we have. I'm going to write equals, equals, and all that good stuff. We're going to do it in the same order on both sides. Okay? It's important that you make sure that both sides are matching. It's a lot easier to tell where you're at, what you need to do. Just keep it in order. It helps. So let's find out what we have to begin with. Fe is iron. We have 2 irons going in. We've got 1 going out. Hydrogens, those are the H's. There are 2 of them sitting right here on the reactant side. And we'll get to that one in a moment. If y'all look, the O and the H are both inside of the parentheses, being multiplied by the 3. So there are 3 H's. The O over here, there are 3 right here. There's 1 right here. We're going to add those together. That gives us 4. And then over here, just like the H, the O is inside the parentheses right here, and it's all being multiplied by that 3 right there. So there are 3 O's. Now, remember our order. We want to start with metals, if we have them. And Fe right here, iron is a transition metal, so we'll start with him. 2 in, 1 out. The easiest way to fix this, multiply this 1 Fe by 2. So we're going to put a 2 right here. Now I want you to notice, this is going to affect the Fe. It's also going to affect the O and the H. So I'm going to cross all 3 of these guys out to remind me that all 3 are changing. So, 2 Fe's, check. The O's and the H's. Now if you look, the O was already being multiplied by 3. Now it's being multiplied by 2 as well. 2 times 3 makes it 6. Same deal with the H's. 1 H multiplied by 3 multiplied by 2 makes it 6 as well. So our Fe's are now fixed. Our metals are happy. We have the H's and we have the O's. Now remember, you're going to want to get everybody else. We don't have anybody else. H's, then O's. We have 2 H's going in. We have 6 going out. The easiest way to do this, notice that all your H's are sitting right here. We can multiply all those H's by 3, and that'll fix the H's. Now I want you to notice though, this is going to affect the H, it's going to affect the O. I'm going to cross both of them out to remind me of that. H's, 3 times 2, makes 6. Now the O's, those are a little bit tricky. You still have 3 of them sitting right here. And then if you look over here, you have 3 more sitting right there. So 3 here, 3 more, for a total of 6. And if you take a look, your equation is now balanced. 2, 2, 6, 6, 6, 6. And that is all. Okay, now if you want to do one final thing, usually pretty smart, put a 1 right here. In my class, we call this 1 and done, and that's just to remind you that this is there. All right, next problem. So we scoot this up a little bit. Draw your line down, separate your reactants and products. You've got C's, H's, more H's, and then C's and H's. So we'll just do C, then H on both sides. You have 2 carbons going in. You have 2 going out. H's, you've got 2 here, and then 2 more over here for a total of 4. And on this side, you've got 6 of them all packed together right there. Now, normally we would start with carbon, but there's nothing to do there. So we have to start with our H's. Now this one is a little bit different. Here's why. you have H's here and here. Now, if we can, we'd like to leave the C's alone. So let's take a look. In order to make it work, I need 2 more H's to make a total of 6. So I need to match the 6 over here. 2 of those 6 are right there, which means that if I can make this 4, this will work. So I put a 2 here. This only affects the H's. Let's recount the H's. There's 2 here. 2 times 2 makes 4, so 4 plus 2 makes 6. That's the easiest way to solve this one. Remember, put 1's in, 1 and done, and that's it. Alright, take a look at number 3. Number 3, a little bit bigger, but we're going to solve it the same way. V, F, H, I. And we're going to do that on both sides. Now, if you take a look at the V's, you have 1 vanadium on the reactant side. You have 2 vanadiums on the product side. It's that 2 right there. F's, you have 5 on the reactant side. And on the product side, you just have 1 just sitting right there. H's, 1 going in, 1 going out. Iodines, the I's, there's 1 there, and there are 10 going out. So 1 and 10. Now, remember, you can take your pick on which ones you want to start with, but in general, good idea, start with your metals. So, of V, F, H, and I, the V is a metal. Let's start with him. To fix this, I have to put a 2 right here to make this 1 into a 2. So I'm going to put a 2 right here. This is going to affect the V, the vanadium. It's going to affect the F, the fluorine, as well. So I'm going to cross them both out. The V's are now 2. The F's are now 10. 2 times 5. Now, our metals are done, so this leaves the F's, H's, and I's. We want to leave the H's alone. So it really doesn't matter. Let's do the F's. There are 10 entering the reaction now. There's only 1 leaving it. The only way to fix this is to make that 1F into 10. So we're going to put a 10 right here. Notice it doesn't just affect the F, it also affects the H. I cross them both out. The F's, 10 times 1. Our F's are now 10. And so are our H's for the exact same reason. Now, your vanadiums, still good. Your F's are good. Your H's are off, and your I's are off. Remember, you don't want to get the I's or the H's quite yet, but if you have to pick, let's do the I's. There's 1 in, 10 out. I can put a 10 in front of this 1 to make it work. So I'm going to put a 10 right there. Now notice it's going to affect the H, it's going to affect the I, both. So I cross them both out. 10 is going to have the same effect. 10 H's, 10 I's. Vanadium's check, 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 and check. Everything's balanced. 1 and done. Let's move on. Now, our next problem is number 4 right here. Same steps. Okay, let's walk through this. There is 1 osmium, 1 OS, going in. There is 1 on the product side going out right here. Oxygens, there are 4 entering the equation right here. And if you look over here, there are 2 exiting the equation right here. Platinum, the PTs, 1 here, 1 there. The chlorines, the CLs, 4 here, 8 there. Now I have my choice. Osmium and platinum are both metals on the periodic table. I can't start with the osmiums because they're both 1. Nothing I can do there. I don't want to touch these O's. Leave them alone. Platinums, normally I would start there, but again, even though they're metals, they're already balanced. I can't do anything. So I have to start with either the CLs or the O's. We want to start with the CLs, the chlorines. There are 4 and 8. In order to fix this, why don't we put a 2 in front of that 4 right there. So by putting the 2 here, notice it's going to affect the PT and the CL, so I cross them both out. The platinum is now 2. 2 times 4 gives me the CL, which is 8. Alright. Now, fix the chlorine, but it messed up the platinums right here. So they're the next ones I'm going to fix. 2 in, 1 out. The easiest way to fix this is to put a 2 in front of the platinum right there. It's going to affect the platinum and the oxygen. Cross them both out. The platinum, 2 times 1, 2. Oxygen, 2 times 2, which makes it 4. Okay, now take a look. Everything checks. 1 and done. And you're done. Okay, next up, last problem on this sheet. Draw the line down. Let's break this thing down. Now, if you'd like, this is a good time. If you want to hit that space bar down there, pause this, work this one on your own, and then come back and take a look. All right. So I'm going to assume you've actually worked this problem. If you still don't feel comfortable with this, just watch and follow along. C, F, and Br. The carbons, 1 on both sides. The fluorines, 4 on the reactant side, 2 on the products. The bromines, 2 on the reactants, 4 on the products. C, F, and Br, none of them are metals. None of them are H's or O's either, so it really doesn't matter who you start with. But you can't start with the carbons. 1 and 1, nothing you can do. So let's start with the F's. You've got 4 in, 2 out. Let's take this and multiply it by 2. So we're going to have to put a 2 right here. That is only going to affect the F's, so let's cross them out. 2 times 2 makes 4. Fluorines are fixed. Look at the bromines. You have 2 in, 4 out. Take this 2, multiply it by 2. We do that by putting a 2 right there. 2 times 2 makes it 4. And it only affects those bromines again. Everything checks. 1 and done. And that is all you need to do for this. Now, a quick note for those of you who are curious. The reason we put the 1s in the state I teach in Texas, we have EOCs as well as the STAR test. Well, and by the time you're watching this, it may be called something else. And they are really, really fond of asking the question, what is the sum of all the coefficients in the balanced equation? These guys right here, if you remember, are called coefficients. And a lot of my students have a bad habit of forgetting that even though you may not normally see the 1s, they are still there. So, if you ask that same question, what is the sum of all the coefficients here? 3 here, plus another 3 here, be a total of 6. But again, that's really probably not something you may have to worry about depending on what state you're in. Just a side note. Anyway, that's all, guys. Hope you enjoyed it, and let me know.